This is DevOps in Agile Way podcast.
Hello again. In the first episode, when I presented the serverless case of Amazon Prime, I mentioned cloud computing models, and this episode is about it. We will explore these models, and I hope that this topic become easy for you after a few minutes, and you will finally properly understand those computing models and what they mean. Well, a few minutes or a little bit more than a few minutes, we'll see. Alright, but before I explain what cloud computing model is, let me just set the stage a little, alright? First, we all know, and I think understand, that clouds changed our perception of processes, approaches, and so on. However, I think we see it through public clouds only. But the truth is that private clouds also exist, and the perception also need to be changed because of them. Without going into details, it is quite interesting exercise to draw the communication diagrams for non-cloud and cloud environments in the companies, right? One of the great sources to start exploring this topic is a team topologies book written by Manuel Pai and Matthew Skelton, which I really, from the bottom of my heart, recommend to everyone. Looking on the other side of the coin, we need to understand how computing models affect our responsibilities and skills we need to provide. This may lead us to something what is called shared responsibility model, and we will dig into it very soon after just explaining the compute models themselves. Cloud computing models. In general, and in one sentence, this is the principle which describes what is in responsibility of whom. And in theory, I could end this episode here, but let me dig a little bit deeper into that. So we can identify multiple layers of every application or service, right? Starting from the bottom, we have network. I intentionally do not go into the element of data centers, like physical networks, power management, air conditioning, physical security, and so on. This is another layer, and yeah, we could explore this, but here I want to focus on the, let's say, SysOps/DevOps/development sphere, okay? So we have network first. Above, we have storages, physical servers, hypervisors, operating systems, middleware, runtime, data, and finally, on top, we have application. Now, the cloud computing model defines for which part we are responsible and for which the responsibility goes to our vendor, whoever this vendor will be. So, in other words, what we manage and what we don't. Simple. The first model, the oldest one, I can say, and I think the only one which doesn't have as a service in the name, it is simple on-premises. So what is on-premises? On-premises is the approach where we host everything ourselves. We own our data center, or at least we have some rack with servers somewhere, or we just have some PC under our desk. I didn't say that. If we host the rack somewhere else, in some shared data center or something like that, the part of the burden is not ours, but still we can think about this as a kind of on-premise. We manage everything, from physical side to applications. This requires us to have all the skills, including other areas and non-technical, like physical security, for example. The biggest value in this approach is that we have full control, and I mean it, full control over our environments. We are in charge. We decide how to build, what to buy, how to place racks, servers, how to paint the walls, and so on. And the biggest disadvantage goes, well, exactly from it, right? So we need to think about every single piece of the puzzle. We need to hire all the personnel we need. And going into the technical aspects, we are facing, or we will face soon, the scalability issues, right? Should we buy 10 racks with servers, or one is enough? Should we buy them in 1 month or maybe 1 year? What we do with unused capacity when we don't need it? Or what we do if we need more capacity and we don't have it? Of course, The private cloud built on top of our data center might help a little with that, but the problem would be there anyway. So to summarize, on-prem means we do everything. Simple. To overcome main constraints, we started to use public clouds. Well, I simplify it right now, I know, but let's stay with this approach, okay? And first model here is called infrastructure as a service. In this model, we leave the responsibility for network, storages, servers, and often hypervisor to the vendors. It means also the physical security, etc., etc., etc. We just select the machine which we want to run. For example, give me a machine with 8 CPUs, 16 gigs of RAM, and 50 tera of disk, right? And that's it. What will be installed on the machine, how it will be maintained, patched, how we will give access to it, all those elements are on us in this approach. This approach is great for better scalability and flexibility and allow us to get rid of many areas which we don't want to touch. And also we try with this approach to get rid of these elements of scalability issues we could have with on-prem. But do not be misled here. I will come back to this later, okay? What is the example of infrastructure as a service? Well, let's go simple. AWS Cloud with their EC2 instances, for example. This is a good picture. What is infrastructure as a service? Next model is called platform as a service. This model goes more into giving the responsibilities to third party, in this case our vendor, right? Operating systems, middleware, and runtime go into vendor responsibility. So this is like a infrastructure as a service plus. In general, this approach gives us the chance to have some services without hiring people who knows how to run them. In other words, we can have something without people with knowledge in infrastructure to run the product. In this model, we care about the code, about the data, but not about the platform where the code is run or data is stored, right? So AWS S3, RDS, relational database service, AWS Beanstalk, those are the examples of the platform as a service, right? We don't care about scalability, we don't care about other aspects of it, we just deliver what we want to run, and well, let's say in some extent we manage it. Finally, we have the software as a service. In this model, we simply deliver the code, all of the rest is managed and maintained by the vendor. So we don't care about anything else in this case. At least that is the way how sometimes sales try to trick us, right? So just give us your code and we will run everything. And it's not entirely true. Yeah, in some cases it will work this way, but not always, and only in the small subset of the whole use cases. From our perspective as users, Gmail, for example, is that kind of service, right? We receive everything. We just need to configure, let's say, our email and maybe some folders and etc., etc., right? I deliver the code, as I said, right? Email address or the person to whom I want to send an email and the content of this email, and that's it, right? Dropbox. This is another example of the software as a service. However, it looks a little bit differently when it comes to design and create a system with the software as a service approach. We tend to think that with software as a service, the whole skills we need is development and maybe some knowledge about cloud. Well, maybe this might work when your company is about to, I don't know, deliver the website with pictures of cats, but if there is something complex, it will not work this way. For complex solutions, you still need to have proper competency around communication, processes, boundaries, accesses, data, operations, deployment, and many, many other aspects. So it's not that easy like it seems to be. Let's consider an example of banking application built with software as a service. I do not claim it is smart or not. I do not claim that it is something like that already built or not. Just an example, okay? The banking application has multiple layers, login, user data control, verifications, account information, account manipulation, loans, deposits, transfers, and many more. In case of this complexity, we need architects to design the application. We need cloud engineers to be able to properly create and maintain the environments. Also to properly design the resources, okay? Cloud engineers together with security engineers must design and create appropriate access management system, both for clients and for the system itself. Proper networking has significant role. You already see it's not that simple, and I just touched the surface. Now we know that software as a service doesn't remove everything, let's say, except prepare code and send to cloud. More than that, we need to understand that the communication patterns, how requests are exchanged between components in the system, those elements are very important because we talk here about microservices where the communication between them is critical. So simply speaking, there is another layer of complexity which needs to be managed. Alright, but this is not the part of our story today. So software as a service sometimes is split into two subcategories: backend as a service and function as a service. So what is backend as a service? Well, this provides server-side capabilities with predefined components like push notification system, authentication, cloud storages, database management, APIs, and so on. This model, or should I say submodel, allows developers to define initial parameters of the service and just care about the code and the main functionality. Second group is a function as a service. In this case, we talk about the computing, like AWS Lambda functions, right? So serverless compute model. We deploy the application code and vendor takes the rest of the responsibilities. Well, in the ideal world, which doesn't exist. Both groups are overlapping as they are parts of the same approach. Now, with all these models, we look differently on our responsibilities. And let's take here database as an example. So if I put the server under my desk, install Linux and MySQL, we can say I have on-premises installation. If I create EC2 instance in AWS, I select Linux machine for it. Let's call it will be pre-installed for me. I install MySQL there. This is infrastructure as a service. I receive the system, but everything I installed there. If I use AWS RDS, so this relational database service, I have to decide what engine of the database I want and the size of the machine. In this case, I will have platform as a service. I don't need to install anything there. I just care about database itself. What is the structure, how to access this database, etc., etc., etc. Finally, if I use, for example, WordPress service to host my blog with MySQL behind it, I will get my installation of everything with this MySQL. We can consider this as a backend as a service. As we can see, we have different set of responsibilities in each of those models. And with that comes another definition. The definition which we, as our cloud engineers, architects, operators, whatever, we need to understand it very, very deeply. So this is what I mentioned at the beginning, and it is called shared responsibility model. So shared responsibility model determines the areas of the responsibility for vendor and client. It clearly sets the boundaries between them and allows to precisely understand the scope of the responsibilities. It is very useful in terms of architecture, security, or governance, and whole approaches and designs of it. So this is the framework, sometimes called security and compliance framework, which dictates obligations of vendor in terms of security. But it is, of course, it's not all here. Now, we can connect the shared responsibility model with different cloud computing models, and we will have the precise knowledge about the boundaries for each type of services in terms of responsibilities. So here we are. I believe my explanation will help you to better understand cloud computing models and responsibilities, which we, as let's call us resource owners, have, right? So hopefully this helps you to feel better in your cloud journey. Okay, so thank you very much for this episode and being with me in this episode. See you next time. very soon.
Thank you for listening to this episode of DevOps in Agile Way podcast with your host, Abeyu Pivo. Subscribe, comment, and do not forget to check our next episodes. Stay tuned. Stay safe. Stay curious.